Hello and welcome. This is Joel from our marketing team. In today's episode of NCTV, we will talk about our program Good Guys Index that was launched in May. And with me today, I have Håkan Fransson, who is technical manager within simulation at Novacast. Very welcome, Håkan.
Thank you.
First of all, Good Guys Index was launched in May. How would you describe the program GGI to those who haven't heard about it before?
The biggest thing with this GGI is that it's a CO2 calculation system for calculation of the casting process, metal casting process, I would say. So that is the biggest thing with it. Otherwise, you can also calculate energy consumption and you can also calculate cost. But we see the biggest advantage right now is the CO2 calculation.
And this quality about the CO2 calculation, is that one thing that GGI could bring to the foundry industry, or is it something else that you want to mention?
I mean, the CO2 is, there are coming demands onto the foundries from their customers that they are having to calculate the CO2 because it should be brought into a life cycle analysis at the end user product. And there we can contribute with the calculation of the CO2 of the castings. And that is a big portion of the CO2 emissions actually in many products.
GGI, is it a stand-alone program, or is it possible to combine it with, for example, Nova Flow and Solid?
It is a standalone product, and you can use it freely without using any other software. And but you can also get it connected with Nova Flow and Solid, meaning that you can export data from a simulation in Nova Flow and Solid. We have also ideas that it doesn't have to be exactly just Nova Flow and Solid. It could be other softwares also on the market that we are connecting to, because this is a general product. It is not intended only for Nova Flow and Solid, and it's also as a standalone, as we said. So.
And what kind of industry would you say that GGI primarily targets? Is there a specific target group?
I would say that there are quite much demands, of course, on the automotive industry. I mean, the foundries that are producing to automotive. So I think it fits very well there. But I think this demand will come on many different sectors in the foundry industry. So it's not only automotive. But I can't say any more. I would say probably energy sector. Most likely you have to calculate, or should calculate, for example, when it is wind power, for example, or other type of energy systems that demands castings. That must be calculated because they are saying that it is very good out of an environmental view, but you have to have the figures, and you have to also have the figures in order to improve your processes and so on, so you can minimize the CO2 emissions.
And this sounds very interesting, Håkan. We will now show a presentation with more information about Good Guys Index, as well as a demo session of the program.
So what is GGI? It is a CO2 emissions simulation program. You can apply different furnaces, different energy sources, different ways to cast a part, and of that reason you can simulate different scenarios how this will be affecting your CO2 emissions. It's also calculating the energy consumption, so that is also possible, and it can also it's a cost calculation program, so you can use it as a cost calculation at the same time. But in this presentation I will focus more on the CO2 emissions, I would say, and the energy. So, who is this for? Yeah, you can say that foundries that cast different casting parts, of course, foundry engineers. That is very important sector for us. Casting designers, that are casting designing the parts. So it's possible for you to actually optimize your casting designs by looking at the CO2 emissions. So it's not only cost and the performance of the part, but also how it performs environmentally, so to say. Purchases that are purchasing the parts, the casting parts from different foundries or different countries, and of course sustainability engineers. The GGI usage, you can say, is that you can compare different casting designs, compare different methoding designs, feeder and gating systems, or if it's for high pressure die casting, the gating and different ways to cast the part, so to say. Compare production in different countries, because that differs, of course, depending on what energy sources are used in that countries, how they are actually normally doing their casting parts. There are traditions in different countries. Compare different foundries and see how they are performing. If you have a variety of different suppliers, then you can compare them and see which one is the best in this aspect. See impact of using different energy sources, and also see impact of using different processes. There are two things, but there are many more that you can change and so on. We will see that when we come into the software. You can calculate the cost, as I said before, and also calculate energy consumption, and calculate, of course, the total and generated CO2 emissions. The GDI CO2 calculation for workflow, you can say, is that you have energy sources here that you have to set up. So a type of source for energy production, or a mix, a raw material CO2 emissions. That could also be a mix, of course. We have like a small charge, not charge calculation, but charge mixing software inside the GDI as well. And then you have transports to customers and of raw material. You have in-data of kinds like weights, parts, feeders, gatings, type of casting, gravity, HPD, furnace type, mold weights, and so on. That must be set there. You have the process editor, which is a separate module where you have select type of process from the templates. We have 4 or 5 different templates. Adapt the process scheme and fill in the correct times and energy use then. And also you have the path editor. The path editor is for calculation the transports. So you have transport of casting to customer, transport of raw material to foundry, and set up a scheme of different transport types for each transport then. And here you have then what comes out. So this is the result out, so to say, in short. You get out the energy CO2 emissions, you get out the energy consumption, and you get out the summarized then CO2 emissions, and then you can start comparing different types of foundries and so on. So here's some of the settings then. So here you have the CO2 settings page, CO2 emissions. So we have possibility to mix different energy sources or use one of them. And we are using, in this case, IPCC 2014 as a source reference for the energy source. But this is, of course, up to each user to whatever you like to have. Or maybe it is some demand that comes from your customers, for example. We also have freight types, and we have raw materials here. Oops, let's see here. For example, the raw material mix looks a little bit different in the real program, because we have now added the values for the raw material. And here you will have a possibility of mixing together, for example, a ductile iron alloy or a steel alloy or whatever. And you can of course also add directly values here for example, for a certain alloy like aluminum alloy EN or AC 46000. So this is the needed in data, and we will go through it a little bit when we come into the software, but here you have the energy source, furnace type, and so on. Process comes in later on. We have the weights, and you get the total weight, and so on. So that is in the project editor, where we're setting up this information. And this is the main screen of the project editor. So here is where you start the software from, so to say. And you can either start by open a project or create a project. of course, and then you can either import the iteration from, for example, our simulation software Northern Solid, or you can import, or you can create an iteration then. So you use a kind of a template or default values, and which you can adapt before you put them into the software then. So this is the whole, you can say, more or less the whole main screen. Then we have a process editor. This is if the first screen describes the so to say the materials and so on, the material melting. Here we have the surrounding processes. So here's shakeout, cutting, feeding, grinding, and so on. And here we are also defining that, so we can set that up. And then we have the path editor, where we are then looking at the calculation of the transports. So this one is for the surrounding processes, and we get, of course, CO2 emissions from this. We get CO2 emissions from the transport, and we get CO2 emissions from the melting, which is there you are using a lot of energy. And also the raw material is one big thing, of course, but that is purchased, but should be counted in somewhere. So here we have the GDI results then, where we have also included in here, we have the total cost savings and so on. We also can compare, so we can, when we are setting up a base, we can compare with others, and then we get the deviation in between them, so to say, on the energy savings and cost savings. And you can see directly how much you have in CO2 emissions, which is a really interesting thing. We have also a value called Good Guys Index, which is a number that we have created that maybe in the future will be something to count on, but for the moment we are focusing on the CO2 emissions. Out comes the results, and of course then you have to select one of the, we had 3 iterations, we select, for example, the base, and then we can see this divided into upstreams, core, and downstreams. Upstreams is before the foundry, like raw material. Core is at the foundry, and downstreams is transports in this case. And here you can see also that we have divided the casting, the CO2 emissions into kilogram per CO2 kilogram, so to say. So it is a kilogram CO2 per kilogram. So it is not summarized any longer. And this means that you get the comparable number. For example, you can see that, okay, our average is 1.3, but in this case we got 1.49. Here we have some room for improvement, for example. Or you can use this as a calculate your average and so on, and then you can see if you can lower the average for the whole foundry, so to say. So this is the result page. We also have an auto report with and without cost calculation. You can actually turn off the cost calculation completely in the software and not focus on that, so that is very easy. So here we have the CO2 emissions summarized then. So we get the CO2 emission from the melting process, the casting process, the casting machine and so on surrounding that, the finishing process, purchased electricity, raw material transport, and transport of the casting to the customer. So that's downstream then. And here you can see a little bit how we are divided into different tasks then, so core, upstream, and then downstream. And the use of the program and usage of the program, purchasing companies can compare different suppliers. So that is very, very good for the purchasing company. Purchasing companies can also include this in a life cycle analysis, and they can ask a foundry, if a foundry has this kind of program, to actually deliver the figures for the casting. And the foundries can use the program to improve their production. Foundries can also use the program to improve a certain product and measure or calculate a certain product. And of course, GDI could be a part of an LCA, life cycle analysis, a complete. So some little bit about the source references. We have taken the CO2 emissions then for energy from IPCC 2014. We have the energy consumption from different furnaces that is taken from the Swedish Foundation. And the transport CO2 emissions comes from a report from the UK government. So that is also that we have put in here. But you might know if you are a little bit working in this area that there could be different figures on the market. So I think you have to select one route and then use that. It should, of course, not be different figures, but it still is, I would say. I will now take a look into the software of GDI. And this is the main screen, as I said. Everything you see here, what has a pen here, you can go in here and actually change. So if you change, for example, from hydro, we can actually start by changing this bit. We don't see everything here. You can take a look at the CO2 emission figure here, and if we go to, for example, coal, you can see that it dramatically increases here. If we go to, for example, another process here, we can select the investment costing process. You will see, okay, that will go up a lot. And you can select, for example, high pressure die casting, and then it goes down and so on. And then you have the furnace types here. We have crucibles and so on. And this is what I mean. This is like a CO2 simulation program, because you can change different things here and see how it impacts the result. And of that reason, you can see if I do this, then I will get much better lower CO2 emissions for this part. So here you have energy source, furnace type, process. We will go to that part. The transport path, you have the raw material transport path, and you have the mold material transport path. Also, that is possible. I mean, for big sand castings, there could be quite much tonnage of sand that has to be transported to the foundry, actually. You have a foundry base engine, which is basically the foundry without any production. And then you have the raw material here, and then the weights. And then you have a little bit other things here, like cost related. And we can, as I said, we can go easily in here and turn off the cost calculation. So then you can see that you get a smaller table here, so to say. It will be smaller in total. And then we have the results down here. If we go first to the settings page, we can see that we can switch the program between HPD and gravity. It's a little bit of how we are setting up different things. I mean, like naming and so on. We have a language section. We have a number of languages that we are supporting. And we have also possibility to work in metric or in imperial standards, so to say. We can also import default values, export default values and so on, so you can use it on another program or another computer. We have the furnaces. So this is the different furnaces, and you can add your own. So this is 2 added furnaces here. We have CO2 emissions here. So this is the energy source. We have the freight types. There are just 4 right now, but you can add more quite easily. And we have the raw materials. And here you can see that we have actually some values of different things here. And you can, of course, go to a mixing here, and then you can put in how much parts that should be in each of them here. So it's quite easily possible to make new variants or combinations that you have at the foundry. We have also another part that it's called the raw materials, and that is the mold material. So here you can put in the right value for the mold material, kilogram CO2 per kilo, or the sleeves or the filters. And we have also default values side where you can set up your default values. The process editor is the surrounding processes then. So here you have, for example, the gravity sand. And if we are setting up with also cost calculation, you will see that we have this a little bit more complete. So it's machine cost, manpower cost, energy usage, time per part, man hour, and so on. And then you get the results of electrical cost, production cost, cost per part. And you get also down here, you have all the values summarized, and that will be transferred to the project editor. And you can easily then, if you go here, you can remove the update, you can change order, and you can change the figures, of course. You can create steps. You can also, for example, add to template. You can duplicate here as well. So here's some default we have here. but you can do your own. So when you have done the first round, so to say, it will be much easier. So you will have to set up a little bit in the beginning, but then in the end, you will have so much gain of it by doing that. So here you can see, for example, we have investment costing. Here's the wax process included, and the shelling, the waxing, and so on. Different steps. We have the path editor, the transports, and here we can set up, for example, in this case, it was China to Sweden, to a harbor, to Europe, to Sweden, or so on. And then you can select different types of freight types, and then you put in the kilometers, and then it's calculated. And that you can set up for the conditions you have. You also have the result page then, which is for the base normally. And here you have, as I said, then the upstream, core, and downstream. And in this case, it was 6.77 CO2 kilogram CO2 per kilo in this case. If we go to the main page, there are some other things maybe to mention here. We can export the data as an Excel file. We can generate a report, as I said, and it's a one-click method. So you just, do you want to exclude? Yes. And then you go to and select where you would like to put it, so to say. And then you have a PDF file where you have all the data. And it's quite comprehensive, I would say. It's a very nice report. Maybe I have some suggestions. There's some, we see if I have a report. Should be a report somewhere, I hope. This is probably a report here, yeah. So here's a GGI auto report, where you have the name of your project, date, default settings data, input data, all the things you put in, a little bit more input data, the process editor, all the data for that, calculated and so on. Also the environmental results then, so all the results comes out here. You have the result page, and you got also source references. So it's a quite nice standardized report. That is good to have. And then also on this side, you have a little bit default. You can set up with default process to use, default path and so on, and also log type. And you have got also possibility for the tooling cost and tooling estimated life, tooling weight and so on. And also the scrap rates. But this is data that you can use as a default values and don't have to change for every iteration. There are also some technical data that comes in if you are using, this is calculated data from the weights here, for example, casting yield and so on. And you have also got some simulation results data here.
So finally, Håkan, the customers who are interested in the program GGI, how should they proceed?
Yeah, they can contact us. They can, of course, go to our homepage and see a little bit more information about the GGI. But I would say that contact your normal contact at Novacast, or you can, of course, send a mail to info@novacast.se to contact us, and then we will contact, and we can, of course, provide you with come to you or have an online meeting and hold a demo of the software so you can see how it works. We are also willing to let you try the program for a month freely.
Perfect. I want to thank you, Håkan, for participating in this NCTV episode, and thank you for sharing interesting reflections about our program, Good Guys Index. On November 14th to 16th, we will participate at Elmia Subcontractor 2023 in Jönköping. And there you will have the chance to meet parts of our team, as well as get an insight of the program Good Guys Index. And as always, do not forget to follow us at LinkedIn, YouTube, and Facebook. Take care. Bye.
Bye.